Now, I want you to help me understand what the heck is Service Mesh and Istio? And is it a hype that's a remix version of something that existed in the past? And is eBPF here to replace it? You know, when we get into replace things that are fresh, not even mature yet.
Yeah, I think the thing that helps you kind of understand what a service mesh is if you think about like data center. You know, if you got a data center, you know, you need some power, you need internet access, you need some physical racks. And then you decide that, look, in my data center, I'm going to use Cisco for the router, maybe Cisco for the switches. I need some storage, so I go get EMC. And I also want some compute, so I'll just go buy some Dell servers and put Linux on it. You might even Pixie boot it, and you have all this infrastructure, right? And you might have a bunch of scripts that you run for each of the layers of the stack. And they all are managed slightly differently, but maybe they're all automatable. So that works. And so when you think about that, though, you're just like, yeah, just data center. I do data center technician. I know how to rack and stack these servers, and I know how to manage them. But imagine if you put a control plane on top of the same stack, then you call it cloud. And then all the stuff on the rack becomes the data plane, and the cloud UI, the API, becomes the control plane. So once you have these two things, it's almost worthy of a new name because of the interaction model. We just treat the data plane as a unified surface, and then we kind of have a more complete, and it feels like a unified API, so much so that you can use tools like Pulumi and Terraform to drive them. But it's underneath the hood, we know it's roughly the same fundamentals, right? There's servers and kernels and power and networking.
Sure.
When it comes to service mesh, the same thing has happened over the last 20 years. You start with, I need networking. Great. So there's still layer 2, layer 3, layer 4. And I think when it comes to layer 2 and 3, I think the world has kind of decided that we can get really far with abstraction. So whether it's a VLAN, using something like VMware, or as a VPC, like in a cloud provider. And in many cases, layer 2 and layer 3, for most people, is kind of figured out. I have an IP, and I can ping the other thing, and it gets there. All right, we're good. Most people don't want to deal with static routes anymore. We're good. And so what's left in that equation? Well, layer 4 and above. So layer 4 through 7, TCP IP, UDP. If you have a DNS server, it's probably going to get exposed through UDP. And so you got to put that thing, give it an IP address, and then you put a domain on it. And if you get a domain, then people can do lookups against your DNS server. If you have layer 7, of course, same thing. Go get an Nginx, Apache, and you can put a domain on top, and then people can talk HTTP. But again, we're back in that old data center model. A bunch of networking services all being exposed through random ports, random domain names, and the config for DNS is very different than the config for Nginx, is very different from the config from Apache. They're there, so you just make it work. But what happens when you put a control plane on that layer? When you put a control plane on that layer, it becomes a little different. First thing you try to do is figure out what is a common API. How do I articulate to the system that these two endpoints should be talking mTLS? I know how to do that with Nginx. I go get 2 certificate pairs, I put them on both sides, and I tell the Nginx configuration to do mTLS. And then I have to tell Nginx or Apache a different way. But if you're Istio and you put a control plane on top, you're trying to now to find a common way to express mTLS, network routes, L4 versus L7, things like permissions. This endpoint cannot talk to this endpoint. All those things were possible before. You can literally not use service mesh and pretty much do everything that a service mesh does with technology from probably 10 to 15 years ago. Guaranteed you could probably do it. You may need some like Nginx extension to make it work, but you totally could. So to me, when I hear service mesh, now what we're trying to do is formalize these network layers into a control plane, data plane split. So instead of thinking about Nginx as one layer, TLS encryption as another layer, we can unify them. Now, did this work in practice? That's the problem. I don't know if it worked in practice because there's also a bit of service discovery, which means you have to integrate with things like Kubernetes or some other tool like Console. And so what I think the world has discovered is that Istio in its current form is pretty heavy, especially the way people tried to roll it out. The thing that makes service mesh interesting is that you need something to hang all of these configurations off of. And the service mesh community decided to do it via identity. So when you write that playlist service, maybe your playlist identity is a token that identifies it as the playlist service. And then you get this token. Now, if I want to have very curated sets of rules and not to make things too complicated, people have this idea that you can just put the load balancer right next to the app. And so for every app deployment, you got this sidecar service mesh deployment. And so if your app was using 8 gigs of RAM and a sidecar also wanted 8 gigs of RAM, now you got 16 gigs of RAM just to run the same service. Some people, they thought the trade-off was worth it. For some people, that's too high of a cost to pay. And so I think the service mesh idea was a good one, data planes and control planes. Now the discussion is, where should the control plane or where should the data plane live? And now you've been hearing things like ambient mesh, where people are saying, hey, maybe we don't need sidecars by default. There's a lot you can do without putting one web server next to every process. You could actually just put one load balancer for the entire cluster and still give it that service mesh feel. And so I think people are revisiting. But to me, when I think about service mesh, it's about unifying the data plane to have a common command and control interface and a control plane that lets you do it.
Interesting. Because it was very confusing even for me, like the ambient mesh vs the original service mesh. And now with the eBPF, they're talking about having everything running at kernel level of your node instead of having sidecars.
And I just think about that as a data plane. So the original Istio data plane is Envoy.
Okay.
You take Envoy, you put it next to your app, and then Envoy has all of these features. You just got to tell it what to do. So from a control plane, you push down to all the envoys what the rules are. And then Envoy it can be heavy. You need to deploy it, you need to manage it. And so if you were to change the data plane instead of one per app, so that means on one host, you might have 10 containers on there with 10 copies of Envoy.
Yeah.
People say that's insane. Like that, why is that the default case? So then you say, well, where could we move the data plane? Well, you could say, let's just take the same Envoy binary and just put one per host.
Yeah.
And then we can kind of configure it that way like we used to do with like one Nginx for the whole cluster. And then when we start to talk about eBPF, again, it may not be able to do everything that Envoy can do. So let's say all you care about is like basic observability, like what's happening, metrics, and you care about TLS mutual auth. Well, those two things you could probably do with a very small data plane. So if those are the only features, let's call that 2 out of 10 service mesh features, then do I really need a heavy data plane? No, I can start with eBPF. Maybe there's some value, maybe it goes faster, easier to manage, who knows? But either way, I can start with that data plane. But if there's features you want to do that requires a more sophisticated data plane, then you can bring back the Envoy binary. So that's how I try to keep this stuff sane. Data planes and control planes, and use the data plane that gives you the functionality that you need.